ฝากเทให้ที่จัน
มันเหมือนกันหมดไหม
เหมือนกันเลย Hello, let me get you the exercise and oh, wrong subject. Just a second. Okay, today we're gonna do something called linear optimization. So go there. Linear optimization. Okay. So go to the usual place and do the linear optimization. Okay, so it's called, the exercise is called linear optimization. Just download it, and while I'm getting the OBS to show up, let me just go to the new screen. Okay, so I'm gonna complain about my camera look like shit, but whatever, I have no choice today. Okay. Now this, and that. Yeah, my full screen. Full screen is too full. The second, browser and window capture. Window capture. Okay. Okay. There we go. Good. Okay, so go to the exercise called linear optimization. And did I share the screen? Oh, I forgot to share the screen. Just a second, let me find my screen. Okay, there. And there, you have my screen. Something to terminal. What's the name? Okay, sorry about that. Okay, so today we're gonna learn how to do your algo homework without actually having to do it. Let me make it a little bit bigger for you. Okay, so the exercise is called linear optimization. Wait a few minutes. Second, I can't find my iPad. Where is it? You can't hear anything. Wait. Does my mouse show up though, guys? Does my mouse show up? Or no?
Oh, we can hear you now. It's on.
But can you see my mouse? The pointer, does it show up on your screen? No. Ah. Okay, that would be hard. 2 seconds. Why doesn't my mouse show up? I really want my mouse. Whatever. I'm just gonna highlight whatever I said. You see it now. How? I don't see it on my screen, but we can see it. Okay, good for you. You see it sometimes. I don't see it on my screen at all. Okay, whatever. Okay, let me do this. I'm just gonna highlight. Okay, so the problem that we are trying to solve, right, is a problem that looks like this. So let me explain what the problem looks like. You may think, okay, Ajahn, this is all theoretical and so on. This is actually more generic than you think. It's actually really powerful technique to solve a lot of real world problems. So the problem that you're trying to solve is some linear function of x. Okay, so your goal is really to find x1, x2, and x3 such that this guy is maximum. Okay, if you think about it, your goal is to find these three numbers. You may think, Ajahn, that's easy, right? Because I just let x1 goes to infinity, x2 goes to infinity, and x3 goes to infinity. Then I'm just gonna get the number as large as possible. Wait, we want to minimize, not maximize. Sorry. Argmin means finding the argument that make it minimum. Okay, so that means your job is to find x1, x2, and x3 that makes this guy minimum. So my argument still stay, right? So for example, you say that Ajahn, that's easy. I just x1 be as negative as I want, right? Then this guy gonna become my negative infinity. Okay, this guy gonna become negative infinity, and you can't win against that. Actually, let me fix my screen 2 seconds. I really want the pointer. I really want the pointer. Is there a way to say display capture? Okay. Prop manual. Wait, okay, this is too hard. Okay, I give up. Okay, we're gonna do it without the. We're just gonna do it with this one without the mouse. That one is too hard. Okay. So what we want to do, right, is you say this thing is unbounded. X1 can go to minus infinity if you like, but that means this guy need to be subject to something, right? This is how you constrain. I said, okay, no. You cannot pick x1 to be minus 500 million. You cannot do that because I require a couple of things. So for example, I require x1 to be greater than 0, x2 to be greater than 0. So that means your hope of getting like minus something, minus 500 million doesn't happen, right? And then x3 greater than 0, then if you only see these last three, right? These last three, x1, x2, and x3 are all greater than 0. You may say, Ajahn, but that's easy, right? Because I know, right? I know. Then all I need to do is make x1, x2, and x3 equal to 0. Then you cannot go below 0. And that's your minimum. But I said, no. You cannot do that because x1 plus x2 plus x3, this first one, which I cannot highlight, this first one, x1 plus x2 plus x3 equals to 1. Now you start, okay, Ajahn, you're getting really picky. And not only that, I require that x2 plus 2x3 has to be less than 5 and so on, right? Now you can see that this kind of problem is called constraint optimization. What we did before in gradient descent, we did it in unconstrained. You can actually modify a little bit to take care of the constraint. But this kind of problem, you can see that it's much harder because of the fact that you have the constraint. Okay. Any questions so far though? I think you guys have seen this. So for example, if you learn calculus 3 or whatever multivariable calculus is, you learn something called Lagrange multiplier, right? Less than 5, not more than 5. Less than 5 is the other way around. Okay, so you probably see it in calculus 3 that typically you do this sort of problem, you do it with Lagrange multiplier and whatnot, and then you minimize it with the Lagrange multiplier variable and so on. But we're not going to do that. Someone write it for you already. Okay, so the goal today is not how to solve exactly this, but to solve this, there are algorithms to do it. So for example, they call it, what do they call it? The walk along the corner thing. They call simplex method. Okay. Okay, there are a lot of ways to do it, but what I want you to learn today is not how exactly it solve it, but I want you to be able to formulate the problem from the physical problem into the problem of this form, because once you have the problem of this form, I say it is very easy to solve. So for example, this is how you solve it. Okay, if you can write your problem, whatever your physical problem is, in this form, you can solve it very easily. Okay, so for example, make sure you can execute this guy, right? If you have problem like with like CVXPY not found, just install it here. Just do this to install it. Just uncomment this guy and run it once, and then you're good to go. Okay, so the way we solve it, all we need to find is we need to describe all these equations, and then we're gonna let the engine solve it, right? You can see that this guy looks almost exactly like the thing above, right? The code here looks almost exactly like the thing above. Okay, so here's what you do. You need to tell them, okay, x1 is a variable, x2 is a variable, x3 is a variable, right? And then they say that this guy, this is not equal like cost, it's not a number. The cost here is a function. If you put type cost, print type cost, right? If you do this, you're gonna say that, okay, it's an add expression of f5 function. You don't really need to worry what f5 means. So this part is an expression depending on x1, x2, and x3. So, and then CP, your problem, right, is the whole entire problem up here. You just need to describe it, right? So you say that, okay, Ajahn, that's easy. Okay, the objective is minimize the cost. That means it minimizes this guy. It matches with the argmin over here. Okay. Subject to, right? When you do subject to, it means that the constraint needs to be this list, right? So for example, I say that all the x had to add up to 1. x2 plus 2, x3 is 5, less than or equal to 5, and all the x greater than 0, right? So this problem contains all the problem description already. Then all you need to do is ask to solve it. Sometimes I'm going to complain to you the problem is not convex and so on. But typically today we only deal with linear, so we should be good. Unless it may complain that the problem is unbounded and so on. Okay, so far good. Once you do that, it's going to give you that, okay, the problem, you can solve it, it's optimal, and this is the value for x1, which is essentially 0. x2 is essentially 0, and x3 is 1, right? And the objective value is 2. So if you check, right, you want to check that 0, 0, 1 actually satisfy all these constraints, right? 0, 0, 1 satisfy this one for sure because it adds up to 1. Okay, x2 plus 2x3, that's exactly 2, right? So it's still less than 5, and all the x is still greater than 0. Are we good? Is everyone good? So it gives you the optimal objective value. Are we good? The objective value is the prop dot value here returns you the cost. You can actually do cost dot value. You want the cost. Is everyone good? Any questions so far though? Okay, so what I want you to try is this guy. How about if I have the problem of this form, I'm not telling you why we want to solve it. We gotta get to why we want to solve something like this. The uncommented line say error. What error? I could tell. Okay. What I want you to do is to try to solve this equation on your own. Okay, and I'm gonna help Saran. What's wrong, Saran? Yes, I know. It's about CVSCY. What does it complain? Something better than that. Something above that tells me exactly what's wrong. What's wrong? It should do something like that. And you cap the screenshot and send it to me though. If it doesn't work, run, put this on Google Colab. So you don't need to fight against your computer. Copy this to your Google Drive and then open Google Colab. So you don't need to fight with your computer. Okay. What I want you to do is the following. Solve this, tell me what's X and Y. Okay, and then I'm going to tell you why we want to solve it. Does it work? 2.95 something. Okay, good. So let's do that together. So check the constraint. So let's do this. So you just need to do X. See if you... Right. So Vanessa, Van is probably correct. Van is probably correct. So you can see that if you try to solve this guy by hand, it's actually much harder than you think. You can do it by hand. So, and actually some program, some curriculum require you to solve it by hand, but I think it's like defeat the purpose of having a computer. And then we say that the cost is 2x plus 3y, right? Okay. Let's get the mechanics now, and then you're gonna learn that this thing is extremely powerful. My company, which hire a lot of your Lunpi, I think we have like 50 or 60 of them already. Some of them work on how to optimize this value for me, and the client loves it a lot because we save people like tons of money by doing the math. Okay, and then we just say that x plus y. This is one of the better library though. There are like 10 ways, 10 library to do the same thing, but this is one of the better one. You can see that the interface looks nice and so on, that it doesn't make programmer life so much harder than it should be. So then I can copy, say, okay, there, that's what we got, right? Let me push it on GitHub as well, so you can see. Actually, there is a solution file there already, so I don't probably I don't need to put it on GitHub. Okay, is everyone good? Everyone got this right? Everyone who actually tried got this, right? Now the question is, Ajahn, it seems like whatever you tell me here is it's very theoretical. Why would anyone want to solve this kind of problem? Okay, good. This is actually a Nobel Prize 20 years ago, or maybe 30 years ago. I don't know. I don't know. It was a Nobel Prize. This was a Nobel Prize, which sounds really silly. It sounds really silly now. Back then it's hard though. Back then it's hard. So let's say the following. Okay. So each day, let's say you want to eat something. Let's say you want to eat something today. Okay. So each day you have 2000 kilocalorie. That's like the power that you need to do something, right? Right. That's the energy that you need 2000 kilocalorie. That actually depends whether you are a male or a female. But I kind of take this kind of number with a grain of salt because it doesn't capture the what's that called, the difference from person to person too well. So each day we're gonna need between 2000 and 2800 kilocalories. Okay, that's from dietary. That's from doctor. Doctor said, okay, you need to eat this much. And but you cannot just eat like protein all day. You cannot eat protein all day, right? You cannot just buy a whey protein and eat them and make 2000 calories. You need at least 56 grams of protein per day, but you need some fat as well. Okay, you actually need some carbohydrate and vitamin C and whatnot, but that's too many variables. So let's do the simple one. The simple one is here, that you need 56 grams of protein per day and 57 to 80 grams of fat per day. And now let's say you have three choices on Grab: chicken rice, cake, or noodles. Actually, you have like 10,000 of choices, right? You have a lot more choices. Okay, but let's put 3 so that now we can work on it. Okay, everyone good? So for example, you can actually eat chicken rice about like 1,000 grams. This number, don't take this number as like real number though. I just make it up. So for example, if to meet 2000 kilocalories, right, you can eat 1,000 grams of chicken rice. That means 1 kilogram of chicken rice, which is a lot. Okay. And then you can get 20 grams of protein. You can get some number of protein, some number of fat, and there's a price that you need to pay per gram. Okay, so far so good. So your job is really to find a combination, right? That gives you this much power, give you this much protein, and give you this much fat, which I already calculated for you, right? I already like type in this table for you, right? There is a cake, chicken, rice, and noodles, and this is the indices. Okay, max kilocalorie, item per protein, and so on. That's good. Okay, so that means this means, so for example, item protein is if you eat 1 gram, right? If you eat 1 gram of chicken rice, then you're gonna get 0.2 gram of protein because that's 20%. Okay, minimum protein is this much and so on. Okay, everyone kind of get the idea, right? There are something that you can eat. You cannot eat cake all day because you're gonna get really fat. Okay, you're gonna have too much fat and not enough protein and so on, and then you're gonna spend a lot of money and so on. Okay, so actually, which one did I open? So for example, if we are at the end of the month, okay, if we are at the end of the month, and then we want to save money, but you want to be healthy as well. So the question is, what is the minimum amount of money you need? Okay, the minimum amount of money you need to stay healthy, to not starve to death. Okay, so far so good. So actually, I need my iPad. Oh, I can actually do this. 2 seconds. It's in. No. I can actually do this, and then I can put it on the side. Window capture, where's the window capture? Let me just make a new one. 2 seconds. What's it called? Air server, iPad, back. And you go here. Nope, cannot go there. It's still too tall. Nope, it's still too tall. Okay, let me make this guy a little bit thinner. Should be thinner. Okay, I like this layout. Okay, I'm gonna keep this layout. Okay, here's what you do, right? You say that, okay, Ajahn, we have, so first we need to decide what are we doing, right? What number are we adjusting? What number are we adjusting? So I think it's obvious from the problem, right, that we are trying to adjusting the amount of cake, the amount of chicken rice, and the amount of noodles we are eating, right? So we're gonna have 3 variables, right? We're gonna have 3 variables, which I'm gonna call chicken rice, right? And the cake and the noodles. Okay. So far so good. Okay. Actually, I type it here. Cake and the noodles, right? So we need some constraint, right? We need some constraint. We need to put in some constraint. So for example, if let's say we want to make sure that the energy that we get is within 2000 and 2800. Where do I put the comma? There. What do I need to do though? How do I specify my problem such that if I require energy between 2000 and 2800, how do I specify my constraint though? This is actually the most important thing from the class that I want you to get. Not how to use the CBXTY library, but how to turn this problem. If I say that, okay, I want the energy between 2000 and 2800, how would you do it? How would you specify it though? How would you specify it? Can anyone tell me? Good. So we need to say something along that line, right? kcal is less than or equal to what, 2800? Yeah, let me write something better than what Adi was saying. Let me make it more specific. kcal, and it's a variable of CR, and it's a variable, and it's a function of three variables, right? CR, CA, and NO, right? The total kilocalorie that you eat depends on how much you eat the chicken rice, depends on how much you eat the cake. Really? Really. So is it better? Oh, now I learned something. OSX is too smart. It doesn't draw off screen. Windows is stupid, or you can say it's smart. It draw off screen. Okay, now we good, right? We good. So we need to say the kcal and this three function as well needs to be greater than or equal to 2000. So that means, can you tell me how do you calculate the total kilocalorie that you eat? Okay, that's what Adi was suggesting. How do you calculate the total energy that you eat? Can you tell me? How do we calculate it? How would we calculate it? Given this table. Given this table, how do we calculate it? Anyone? So for example, right, we just multiply them up and add them together, right? So for example, that's CR, I never write it down, but it actually means this is the number of gram of chicken rice you ate, right? So if you ate 100 grams of chicken rice, then you're gonna get 200 kilocalorie because of that number 2 over there. How do I make sure that my pointer exists? So hard. I'm gonna fix that later. Okay, so it's quite clear that all you need to do, right, is to do 2, right, multiplied by chicken rice plus 10 times the cake plus what, noodles, right, plus 1.8 times the noodle. Is everyone good? And this is your kcal, right? You want to make sure that this number is less than 2800, and you want to make sure that this number, the same number, okay, is still this. Is greater than or equal to 2000. Everyone got the idea, right? Right, that is linear. But actually, most of the problem that you're gonna see in real life is linear. If it's non-linear, then you either give up or you do greater than. Okay. Is everyone good? Any questions so far about these two expressions? Okay. Any questions so far about these two expressions? Right. This is the total calorie that you ate. This is the left, and this is the right. Okay. So far, so good. But there is a much better way to write this. There's a much better way to write this. I claim that this is a dot product, right? This is a dot product between 2, 10, and 1.8, which you can call this as, I don't know, what did they call it? I called it item kcal. Okay, dotted, right? You know the dot product, right? You multiply it elements wise and you add them up, multiply by CR, CA, and NO. Okay, so the dot product is much easier to write, and this is what happens over here, right? So for example, the total kcal, this is how you calculate it, right? Intake is that array, right? That array of that three things, right? And then kcal, the total calorie that you ate, is going to be the dot product between the intake, this guy, and the item kcal, right? Is someone good? That's how I get this. Okay, that's how we get this. Okay, Typically, it's much easier to write it as a dot product. Okay, but we are not done yet, right? Or we are not done yet. We need to figure out how to satisfy the protein and the fat, which I think by now you kind of understand, right? You just take the dot product. You just take the dot product of these two, and you get the protein and fat, right? And you know, when you take the dot product, it's a linear in terms of this variable, right? It's linear in terms of this variable. Are we good? And then you can calculate the total price as well. Now you have everything, right? Now you have everything, which means you can define your problem such that it looks like this. Okay? You can define your problem such that it looks like this. So that means you want to minimize the total price, which we define above as a dot product. Okay? And the constraint are all these. Okay, and then you can solve the problem, you can print all the value, and then if you run it, oops, what does it complain? Item prices not defined. Okay, because I forgot to do this. Okay, so far so good. So this, it tells you that you should eat 115 grams of chicken rice, 161 grams of cake. I think I put the cake too cheap. Even though you want to save money, you eat the cake. Like I said, don't trust the number, and you want to eat noodles, 83 grams. That's how you satisfy all these at the minimum cost. Now you think it's very interesting, right? I don't know. I hope it sound interesting that you can solve the problem exactly that you never thought you can solve before. Because now, even though now you have constraint, in real life you have tons of constraint. Are we good? Any questions so far though? Any questions so far against this? If you want to see the spoiler, here's what you do. You double click this guy, and then do you remove the display equals to none? And then you get, right? For any of you know CSS. So this is the problem that you're trying to solve. Are we good? Any questions so far though? Any questions so far? This is one example. I want to show you that we can solve a lot more problems than this. But this one was a Nobel Prize for economics about 20, 30 years ago, because there is a thing called poverty line, right? They want to calculate what is the minimum income people need to survive in a healthy way, right? They actually go collect the price of every item, find the nutrition value for each one of them, right? And then they do this kind of thing to figure out, okay, what is the minimum amount of money people need to survive? So for example, in Thailand, I think it comes down to about 100 baht per day. Anyone earn less than that is a poverty line. And this is a very important economic metric to see how the country developed. About 30 or 40 years ago, when Mr. Prem, he is dead already, Mr. Prem was a prime minister, 50% of the people is below poverty line. Think about that, 40 years ago. If you look at the poverty line in Thailand, it went down by a lot. Okay, it's probably increasing now given the COVID situation and so on. But it decreased from 50%, now it's probably below like order of 1 to 2 or 3%. Okay, we have improved a lot. Oh, so this is a very good indicator of how a country is developing. That's why he deserved the Nobel Prize. I don't remember the name of the guy, but this was a Nobel Prize a long time ago. But he actually collect all the data. He has more than 3 menus, so this is like a mini version. Okay, so for example, I want to show you that this technique is really powerful in answering the question that you never thought that you can answer before, like what you should eat today. So to do that, let's make sure that you actually understand how to do it. Okay, let's make sure that you actually understand how to do it. So I'm gonna let you solve the next problem. The next problem says you are really rich. Money is not the problem, but you really want to get buff. So you want to maximize the protein that you eat, right? So I'm asking you 2 questions, right? The first question is please maximize the protein and give me how much money do I need and what should I eat? Are we good? If you get the answer, tell them in the chat so I know that you got the answer. Okay. I want to know how much money do I eat to get really buff with the protein, right? Like you're gonna buy whey protein. And what should I eat? Okay, I'm gonna let you do this. And once you do that, you do 2.3 as well. It's probably the same thing. Okay. If you want to minimize the fat, you want the low fat diet, what should you eat and how much money do you need? Eat a bunch of noodles? Maybe. It's your job to figure it out and tell me. Maybe. I don't remember the answer to. But you still need to eat some fat, right? That's what you need to do. Because to stay healthy, you cannot just have like all the protein. You still need some fat. So it's not quite obvious. It's not quite obvious what to do. Which is why we need this kind of problem. Because constraint optimization in general, except this guy, is in general is something called NP problem. I think for those of you who learn algo, you kind of know what this word means. It means there is no easy, fast solution that guarantee the answer. There's no easy, fast solution, except this one linear actually fast. Like you can see it's like really fast. Even though it's fast, internally it's actually ON cube or LON to the fourth. Internally is ON to the fourth or N cube. Yeah. NP problem means you cannot solve it in polynomial time. Actually, you cannot. Which one? You cannot check it in polynomial. Whichever one it is, I don't remember which one is which. But in general, it's hard. Constraint optimization. But this one gives you the answer right away. If you get the answer, tell me in the chat what should I eat. And by the way, I'm eating luchin ping because I'm so hungry. which probably not on this table. Okay, so let me help you with that. You can actually just do this because all the variables is defined for you already. And then minimize the what? Protein. That's why I say that this library looks so nice. Maximize. There are other libraries that try to do the same thing as well. This one has the nicest interface. And this is how you stay healthy, and that's it, right? Let me just copy this. Unbounded. Oh. What? It has to be, oh. Why did unbounded? Is there anything with no fat? No, yeah, unbounded. Have to be bounded by fat. Did I type something wrong? 2 seconds. What did I do wrong? We define the variable, maybe. Wait, I just copied the whole thing. I probably overwrite some variable that I don't know. Oh, now I know why it's unbounded. Now I know. Sorry about that. Let me make sure. Intake greater than or equal to 0. To the CR greater than 0, NO greater than or equal to 0. And because that's the reason it say unbound is that you can eat as much as protein if you can regurgitate your chicken rice out as a noodle. That would be funny. Okay, back to work. there. And like Saran said, you should eat a lot of noodles. You want to save money. If you want to be really buff. Okay. Does everyone got this? Right? I added 3 things because I forgot to tell you that you cannot eat noodles and then put out as a cake. What's the prop dot value? The prop dot value is actually the objective value. It's actually this guy, the objective value. Oops. So for example, it's the same thing as protein dot value. Just I try to optimize it. Okay. If you want to see how much money you need, right, you can print total price. Okay. So you need 208 baht if you want to get really buff. That's what you need. And you mostly, if you think about it, this guy, if you eat the protein, the thing that prevents you from eating infinite number of chicken rice or noodles is the fat, right? So if you print the fat, it should hit that constraint, or maybe, I think, or maybe the total kilocalorie. Yeah, we can print the fat. We can print the what? Kcal. So there, you hit the fat at 8,000. But you cannot just eat the noodle because it doesn't give you enough energy, right? That's why you need to eat the cake as well to meet the 2,000 kilocalorie. So you can kind of see this kind of problem. If you do it by hand, then you sort of screw. You can actually do it, but it's hard, and there's a lot of things that you need to make sure. Okay, if you're interested on how it does the magic, Google this word simplex. There is a lot of video that explain it much better than I do. But what I want you to do is to, yeah. But this one is closer, right? 7 baht closer. Huh? If you want to get the minimized fat, then this is what you need to do. Minimize, and then this will be the fat. Okay. So then you're gonna get 69 grams of fat, which is, I think it's a constraint, right? Which is exactly the constraint, about 69 grams, or whatever the number. 57. Okay, you cannot eat 57 because 69 is a minimum. Okay. And that's because you need to eat enough food for 2000. Otherwise, you can go lower, right? Any questions so far or any questions so far? I want to make sure that you can do these 2 examples. Okay. Anyone got it? Anyone got it? The number? The trick here is to put these 3 guys in. Let's see how much money you need. 203. 2 baht more. Anyone got the number? Adil, did you get the number? Because what we're going to do next is much harder. It's much harder. I want to at least you get the basic down. Adil, Van, Saran, did you get the number? Okay. Okay, let's continue. This one is start to get much harder. Okay. Okay, let me teach you something about the gas in Thailand. How we produce the gas in Thailand. Okay? Because this is actually the exercise that I went and teach PTEP. Okay, so the ratio. So you may ask Ajahn, this kind of problem is very limited because the thing that you can solve only looks like this, only linear, right? You can only solve linear problem, but in real world, there's a whole bunch of other functions, right? That is non-linear. I said, yes. Just listen to me. A lot of things are actually linear, but you may not think it is. Okay. So let me tell you about how we produce gas in Thailand. So the gas in Thailand, right? They produce it from Ao Thai, what's it called? Gulf of Thailand. So we have Gulf of Thailand. Gulf of Thailand. So Thailand looks like this, right? With something here and something there, and so on. And they need to go into the sea, right? They need to dig up the platform in the sea. Okay, and they dig up a lot. And so if you are one of those people who try to like, what's that called, ทวงคืนพลังงานไทย to protest PTEP, then trust me, Thailand do not have that much gas, and it's much harder to dig. So they need to dig a whole bunch of holes in Gulf of Thailand to get the gas for you to generate the electricity. Okay, most of the use for the gas is electricity. Some of it goes to your plastic, some of it goes to your what's that called? ถังแก๊สที่บ้าน your gas, your cooking gas. Okay, here's the deal. Here's how it works. So each day, okay, people in Thailand, they call it EGAT, the energy something company, the one who actually make the electricity, the burn the gas to make the electricity. Okay, EGAT tells, okay, I need 200, I don't know, SCF, million square foot, million standard cubic foot, a lot of gas, some unit of gas, SCF. Okay, so that means PTEP owns a whole bunch of platform in the sea, right? So this, if you open everyone at 100%, right? If you open everyone at 100%, you should be able to produce, let's say, 500 SCF. Someone get? Right? If you open everything in Thailand and send it to EGAT, you're going to send it 500 SCF, which you don't want to do because it's a gas. You have no storage for gas. You have storage for oil, but not for gas. Okay? Because gas is very hard to store. You need like a really huge tank, and you need a thick steel, and you need to make sure that it doesn't explode. It doesn't like float away. It doesn't, you don't keep the gas. So that means what you need to do, right? You're not going to open every one of them. You're going to open some of them. Okay? You're going to turn on some of them. Let's say these three green guys already gave you 200 SCF. Okay? These three green guys are going to give you enough 200 SCF. Okay? These three green guys can give you enough 200 SCF. Or these three orange guys, these three orange guys can give you enough gas as well. Okay, these three orange guys can give you also 200 SCF. So now it's the choice, right? It's now the choice. Okay, it's now your choice. Which one do you want to open to send the gas to EGAT, right? It's now your choice. Let's say now you are the gas field operator, right? It's now your choice whether you want to pick the green or you want to pick the red. Okay, that's good. So how much gas do you want to generate from each guy to produce exactly what EGAT is asking? So here's the deal. Okay, the way we choose is the following. The way we choose is the following. You know, it's a company, right? So they choose it based on money. So they're gonna choose it based on the money. Whichever one generate you more money, you're gonna open that one. We get you're gonna choose that one. Whichever one generate you a lot more money, then you're gonna choose that one. Okay. So to generate more money, here's the deal. Since you are going to generate 200 SCF anyway, right? You're gonna get the same money for green and the blue. For your green choice and the blue, you're gonna get the same money for gas, right? Same money for gas. And by the way, that 200, the technical term is called nomination. Yeah, let me tell you about the business, and then we're gonna solve a lot of problems with the business. I want to make sure if you have questions, then just ask. Maintain costs, not really. Maintain costs is much cheaper than the revenue. Most of the money for oil and gas company are the sunk cost. How much is it to dig and how much is it to build the thing in the middle of the sea? They even have better internet though. I asked them, do you have internet? Like in the middle of the sea, they said they do, and it's much better than your home internet. It's a satellite one, I think. That's it. They can even like conference call with me on Teams. So they have quality internet. Okay, so you're gonna get the same money for gas. So the thing that you choose, here's the thing. And when you produce a gas, right? When you produce a gas, you actually get a whole bunch of other things. You're gonna get water. That's of course, right? When you drill something in the floor, you're gonna get the water. After you get the water, there's also oil, because gas and oil, if you learn chemistry, it's actually the same thing. It's hydrocarbon. The oil is the gas that is just a bit longer in the chain, in the carbon chain. Okay, so that means each of the well gonna produce different amount of oil, right? Some of them gonna produce like 3 oil, 2 oil, 4 oil, right? 5 oil, 6 oil, and maybe this thing is 1 oil and 3 oil, right? So that's good. So the set of green, if you open this set of green, what you're gonna get is what? 4, 5, 9, 15 units of oil. Okay. So that's gonna be your extra income from the 15 units of oil. So this actually is a lot. But oil in Thailand is actually low quality because it has a lot of sulfur and so on. Unfortunately, if you open the blue set, the red set over here, what you're gonna get is what? 2 plus 3, you're gonna get 8 units of oil. Okay, so you're gonna get 8 units of oil. So which one you can pick? That's clear, right? That means you just want to pick the 15 because you're gonna get more money for 15 in a day than the 8 units of oil. Okay, is that good? So the whole idea is the following. Okay, so the whole idea is the following, that you want to optimize the following, right? You want to optimize the oil. You want to maximize the total oil. Okay, you want to maximize the total oil, but you are subject to, okay, you are subject to that you can only produce 200, right? You may ask Ajahn, if you want a lot of oil, all you need to do is like turn on everyone to the maximum. Yes, you're gonna get all the oil in the field, but you're gonna produce too much gas and you don't know what to do with it. Right? People don't mind Bitcoin that much, right? If you produce 500, then you don't know what to do because you only use 200. 300, you might need to do something with it, but you cannot just like throw it away like water. Water is a lot easier to throw it away, even though you need to some treatment. But the gas, this is like flammable. If you throw it away and someone light up a cigarette, then everything blows up. So subject to nomination. Okay, subject to the nomination, the 200 mmSCF, right? I put 100 in the sheet, but that's the idea. Subject to the maximum amount you can produce, right? And also subject to some physics. This is annoying, but yes, there's some physics, right? That each of the well has some limit capacity, right? So that means the gas you get from each well is going to be greater than or equal to 0. Actually, let me say this. It's going to be between 0 and some number, I don't know, 5. Okay, right? So you can see that this is actually a linear problem if you try to solve it, right? It's a linear because total oil, that's very easy. You just sum of the CTR. This is the condensate to gas ratio. It tells you how much oil you produce per each gas. CTR times the gas I. And then you say that the sum of the gas is going to be less than or equal to 200. Okay. Any questions so far, or any questions so far? So this would be good if this is the only thing you need to do, then this problem is easy, right? Any questions so far though? Any questions so far? This is like oil, total oil. It's like total calorie or total protein that we did. Any questions so far though? Any questions so far? Any questions so far? Okay. But your life is a little bit harder. Okay. Let me tell you, your life is a bit harder because oil in Thailand is of a low quality. Okay, so let me copy this and go to the next page. Oops. Oil in Thailand is actually of a low quality. So this is what happens when you produce oil in Thailand. It comes with a lot of lead, Hg. Okay, this is the lead. It's toxic. It's so hard to remove. It's actually not that hard to remove because it's heavy. Lead is heavy. So to remove it, you just need to let it sit there for quite a long time, and then it's gonna go down to the bottom anyway. Okay, you just need to let it sit there. Lead is PV. So what is Hg? Hg is Fallout. What's Hg? What's Hg? Hg is the correct symbol. What is Hg? Wait a second. Hg, what's it called in English? Mercury. Ah, sorry. It's a mercury, not the lead. Mercury. Sorry about that. Thank you very much, Saran. You are expert in chemistry. Okay, because it comes with a lot of mercury, but mercury again is heavy. It's heavy, so it's gonna go down to the it's gonna go down to the bottom of the well really quickly. Okay, your container gonna have the bottom with lead and mercury and whatnot. Okay, so what you wanna do? This thing comes with oil. Okay, and each of the well, right? Each of the well has the characteristic. Some well has a lot of mercury. Some well has less mercury. Okay, but at the end, when you produce from all these well, right, you put it down. It's like your recycle bin, right? You can separate your trash you want. Someone's gonna throw them all in one bin anyway. They're gonna throw all the oil in one bin, and that bin gonna be totally mixed. So you want to make sure that this bin, the content, the percentage, the ratio of Hg over oil is within certain limit. Okay, this is what you want to make sure. This is like real life. You want to make sure that the ratio of the mercury to oil is within a certain limit. Okay, so far so good, right? If you produce more oil, you can produce more mercury, but as long as you keep it within the ratio. Okay, so here's the thing. Okay, so here's how you calculate the mercury concentration. Okay, to calculate mercury concentration, what you need to calculate, right, is it's a gas. So we need to calculate the amount of oil that we get multiplied by the mercury. So this is like total gram of mercury, right? Total volume, actually it's total volume of mercury. Divide by the volume of the oil. Okay. So that's good. Everyone is convinced, right, that this guy is clearly some sort of ratio, right? Some sort of mercury concentration. You divide by the amount of mercury that you produce. Okay. And you take the amount of mercury that you produce and divide it by the amount of oil that you produce, and you want to make sure that this thing is less than or equal to 2000. Okay, everyone good? Everyone good? All the top part here is good because that's linear. Okay, it's linear. All the top part here is good because it's linear. But this guy over here that I just showed you, right? This guy is unlike what we have seen before. We have seen this kind of thing before, right? We have seen this kind of thing before that it looks like something multiplied by something and then I sum it up. That's what is called linear. Okay, but for this one, it doesn't look like linear. Think about this. This guy is not linear. There's G on the top and there's a G on the bottom. Okay, the rest are fine. The rest are linear. So the question is, anyone has a good idea though? How do I make this guy linear? How do I make this guy linear? At least for the ratio. What do you think? Take the I out. How? This thing is sum over I, by the way. Anyone? How do I make it linear? Your problem, right? Your problem is clearly with this guy. This guy should not be at the bottom. That's no closed form. Very good. So your problem is because this guy is at the bottom. All you need to do is move it up top, right? All you need to do is move it up top, and then you're gonna get something linear, right? So for example, you're gonna get the sum of GI, CGRI multiplied by HGI less than or equal to the sum of 2000 multiplied by GI multiplied by CGRI. And you can actually subtract the two. You can actually subtract the two, right? We learned the property of the sum, so learn it with me. Right? We can subtract the two, and this guy is linear. This guy is linear, then we're good, right? That means I want to show you, this is the first one, the easiest one, the most obvious one, actually. Okay? This is the most obvious one to show you that when I say that we can solve linear problem, there are actually a lot of things that doesn't look like linear, but it's linear. So for example, the ratio. Okay, so this technique is really, really powerful. Okay, technique is really, really powerful. So this is what I need from you. Can you help me figure out what is the total amount, how much gas should I produce from each one of them? Okay, based on this. Okay, so here's what I recommend. Here's what I recommend you to do. Okay, so you can say that G, right? I actually put GS is CP dot variable. Oops. And the number will, right? So your GS is now, so this is make an array. This makes an array. Okay, this is array of n well. Okay. This is an array of n well. And then the next thing that we do, right, is to define all the things that we need, right? So for example, total gas, right, is going to be Tp.sum Ts. Okay. Or we can say that Ts greater than or equal to 0. That's another constraint, right? Total Ht is going to be Ts with H at CTRS. Oh, I need to multiply element wise. Tp.sum Ts multiplied by CTRS multiplied by STS, and then total oil is going to be Ts CTRS. Okay, that's it. So we want our problem to be. Let me show you the first one, then I'll let you do the next one. Okay. So the objective is called objective, right? Objective. Objective is total oil and constraint. So constraint would be total gas has to be equal to the nomination, right? And then all the gas needs to be greater than 0. And here's the magic on when you use the array. It makes your life so much easier. Less than or equal to potential. This is the physical limit. This is a physical limit. Production limit. And you want to make sure that the ratio works. So we did it before, right? That all we need to do is total Hg is less than or equal to 2000 multiplied by total oil. And then you can say prop.solve. Not pick the off. It has to be CT.maximize. And I'm gonna tell you how much this guy is worth. Minus infinity. Why is it? Why is it minus? I want to maximize it. Something. Oh. Throw up something. Invisible. Okay, that's new. Invisible, that means something is conflicting. Let me remove this guy first to see if it did I screw up something? Let me go see the solution 2 seconds. Probably screw up one thing. That's exactly what I did. That's exactly what I did. What did I do wrong? After the fact. Really? Kidding me? Wait, that's wow. Wait. I thought they are exactly the same thing. Speaks insane. What? Whatever. Probably got something funny inside. Okay, so let me show you what I did. Okay, so I define G as the gas to be an array of, I don't know, 4 numbers, 4 numbers. Okay, and then I say that the total gas is simple, just the sum of every gas, right? And then I say that the total mercury is a gas multiplied by this factor, right? You multiply this. Oh, now I understand. So these two are numpy array, so they multiply element wise. So you get the so you get whatever that you need to dot it with the GS. Okay, and then you get the total oil. Okay, and you get the total oil. This is how you calculate it, and then you just define your problem exactly the same way you did before, and then you make that, and then you find that okay, this is how much you should produce the gas from each one of them. So it said produce 8 from this, and produce 2, and produce what 80 from the third well, and produce 40 from the fourth well. Okay. Any questions so far though? Any questions so far? Okay, you have the solution already. So if you want, you can just copy and paste if you like. So far, so good. Any questions so far though? Okay, as simple as that. So I did exactly what Adil and Van was suggesting to me. Just to move this guy to the other side, and you're good. So let's look at the other one. Let's look at another one. This one is actually very important. This one is actually very important. So you have all your variable, right? Let's say, what if I want gas number 2, this guy, gas number 2, and gas number 3, such that the difference is less than 50. Okay, we want gas number 2 and gas number 3 to be less than 50. We want the difference to be less than 50. So that means if you look at this, it means that you want the absolute, right? You want the absolute. To be less than or you have to go to 50. And this is like sort of linear if you think about it. Right? So you want G2 minus G3 to be less than or equal to 50. This thing is sort of linear except for the absolute, right? Because it's like linear on both sides. If you think about the absolute function, this is what it looks like. This side is also linear. This side is also linear. What do you do? Anyone has a good suggestion? How do we make it linear though? Anyone has a good suggestion? If you can answer this one, then I'm so impressed. This is not trivial. This is not trivial. But once you see it, you know that it has to work. This is not trivial. This is not trivial. Or it's trivial if you know exactly what the absolute means. Okay, so let me give you a hint. Let me give you a hint. We want to make this guy linear. if I know that G2 minus G3 absolute is less than or equal to 50, what do I know about G2 minus G3? What do I know? What do I know? If I say that the difference between your money, yes, very good, Tanawin. It means that this guy has to be less than 50, right? And then minus 50. And that's not how you need to do. Because it means that this guy has to be G2 minus G3, has to be less than or equal to 50, and G2 minus G3 is greater than or equal to 50. And that's it. That's all you need to do. Right? If I let me just remove the spoiler because I probably highlight everything for you already. Right? This is exactly what it means by absolute. That means you just need to put these two in. So let's do exactly that. Let me copy the thing above. And right, all I need to do is to say that okay, G2, right, minus G3 is less than or equal to 50, and G2 my G2 let me just define new variable called this is G2 minus G3. Right, and I say that diff has to be less than that, and diff has to be greater to minus 50, and now you can solve it, right? Oops, what did I do wrong? Invalid syntax because I forgot the comma. G is not defined because I call it GS. Okay, there. G2, oh, not G2 and G. Did I say G2 and G3? Yes, G2 and G3. Okay, good. G2 is this guy 70 and that guy 20. So the difference is still within that range, right? This is what it gives you. Is everyone good? Yeah, everyone good. This is the absolute of the constraint, right? If you know what the absolute means, this is what you do. Any questions so far though? Any questions so far? Now I want you to see the versatility of this. This can solve you a whole bunch of problems. Okay. So the third thing is the absolute of the objective. Okay. The third thing is the absolute of objective. Here's what happened. Let's say if you want to produce as close as possible to 350, even though we used to do this, right? We would do something like this. We would do something like this. Typically, we would do oil minus 350 and then square, and then minimize this, right? But that's not linear. That's clearly not linear, and you have no hope to make it linear because it's in nature quadratic. You have no hope to make it linear. But this thing is kind of close enough, right? If you want these two numbers to be as close as possible, you could say that oil, the absolute oil minus 350 to be as low as possible. Then that's what you meant, right? If you want something to be as close to that number as possible, then you can say that the absolute is minimized. So this is what we got, right? So basically, this is what we want to do. And we know by now that this guy is clearly nonlinear. Right? This thing is non-linear, but that there's some hope that to make it linear. Anyone has good question? Anyone has a good answer to this? How to make it linear though? How to make it linear? This clearly cannot belong here. This clearly cannot belong here. Yeah, this one is not so trivial how to make it linear. I want to show you that absolute of the objective. This thing gonna be what you see a lot. In machine learning, this is called L1 optimization. It shows up a lot in machine learning as well. Okay, so to do that, you need to do something really clever. You need to do something actually pretty clever. Okay, you will need to introduce something called auxiliary variable. Okay, the auxiliary variable, because at least I'm gonna make the objective linear. Right, I'm gonna make the objective linear by introducing a new variable. Okay, and I say that this guy has to be less than or equal to t. Okay, can everyone see that this and that is exactly the same problem? Okay, the term for this guy, this kind of thing is called epigraph, but you don't really need to care about. Okay, any questions? So I want you to see that these two guys are the same, right? I just introduced you a new variable. You might think that, okay, Ajahn, this should be equal. It actually should be less than or equal. You want to bound it. You want to bound this guy. Okay. Equal could work, but you cannot turn it the other way around. But if you bound it with t, right? Think about t as like your upper bound for this guy. Okay, and then you minimize the upper bound. So that means, in effect, you make this guy as small as possible because you minimize the upper bound. Are we good? And then once we have this, once your absolute is in the objective, right? You can use exactly the same trick that you did before. Right? You can use exactly the same trick as you did before, such that this guy is less than or equal to t and greater than or equal to minus t. Okay, seven good. We want to produce as close as possible to 350. So we start with this, we turn it to here, right? And then we can use exactly the same trick as Tanwin suggests, or Adil suggests, who was suggesting Tanwin and Adil was suggesting. Okay, to do it. Now it's linear, everything is linear. And this problem is exactly the same thing as the problem above. Okay, so far so good. So let's do this. Let's do this. Before I want to show you some really cool thing. I want to show you some really cool thing. So let's do this. Let me get rid of these two guys about the diff, because we don't care about the diff anymore. Because we're going to introduce a new variable, right? So we going to be p is dp.variable. And then we're going to say that the difference is calculated by total oil minus 350. Right? So we can just say that the diff is p and diff is minus. And then you have it solved and it typo. And this is how much you should produce. Okay. And you can just print t the value. I think it's 500. Right. So you produce in total, the bound is 557, which should be exactly the why don't I keep using? Oh, because I forgot to minimize t. That's what happens. Unbounded. What? Why is it unbounded? Oh, I want to minimize t, not maximize t. Oh, error. And that's what I put in the warning that you may need to change them. So 2 seconds. TBC, that's the most famous one. Server TBC is not installed. What do I do? I think it's called Microsoft. Anything that's installed is okay. That works. Okay. Now you need to put it here. The solver is the algorithm. Like I said, this kind of thing you don't want to write it yourself because there are so many edge cases that you need to take care of. Even the one that's built in here doesn't do the correct thing. So that's why I said don't even bother to write it yourself. If it does the correct thing, then it should work right away, right? So okay. Any questions so far though? Any questions so far? You get this, right? So you produce exactly as like 250. That's what you did, and this is how you should open it. Okay, it's not obvious if you try to do it the first time. It's not obvious at all that this kind of problem can be solved exactly. It's turned out to be able to solve exactly, and it's fast, like really, really fast. Okay. Any questions so far though for this? I want to show you that it's possible even if the objective is the absolute. Okay. And you can see that t, the value for t itself actually converge to the value of the different. So it's the same thing, 10 minus 10 and 10 minus 11. That's the same thing. Okay. Any question though? Any question? Any question? Any question though? Okay. If there's no question, I think this you should see by now that a whole bunch of things looks linear. So the next thing is something that doesn't even look like linear at all. The sum of the absolute. This is even worse. Okay, this is even worse. It's called the sum of the absolute. Right. So for example, if your boss say that G1 need to be certain value, like this is what your boss say, right? He wants to open the first value 50 and 15 from the second, the third, and the fourth, right? But if you think about it, they don't add up to 100 at all, right? They add up to like a much number. Like, so for example, your boss is telling you some nonsense that he wants this number, but I say, but it actually violates a whole bunch of constraints. You cannot do that. So the next thing he said, okay, do something as close as possible to what I want, right? So kind of makes sense, right? To say that, okay, maybe the difference between what your boss is saying and what you actually do is minimized. But you have many things that your boss wants you to do, right? You have many things that your boss wants you to do, so you can sum it up. Kind of makes sense. Okay, so far so good. So now then you can tell your boss that, okay, but the thing that you'd asked me to do is not linear, right? But the thing that you asked me to do is not linear. What do you do though? What do you do? But this one, some of you may have a good idea on how to do it. It's not obvious though. And this actually has a name. It's called taxi cab norm. It shows up a lot again in machine learning as well. This thing is called taxi cab norm. If you want to know where the name comes from, it's actually come from the fact that if you go somewhere in New York to another place in New York, then the distance that you go, right? This is like your discrete math homework. The distance that you go, no matter how you do it, you can go up and to the right, or you can go up, right, up, right, up, right. The distance are the same. Okay. So the red, the blue, and the yellow, if you add up all the length, they are exactly the same. That's why they call it taxi cab norm. It actually satisfies all the norm, right? If you learn linear algebra before, there's a definition of the norm that it needs to satisfy. It actually satisfies every one of those. Anyone has a good idea how to make this guy linear? How do we deal with the absolute though? Think about this. The problem here, right? The problem here is clearly with the absolute. If it is a sum of something, right? If it's a sum of x, then we know how to do it. The problem here is clearly with the absolute, right? So how do I get rid of the absolute in the objective though? Can I move it down somehow? Anyone has a good suggestion though? Can we move it down somehow, the absolute? Anyone has a good suggestion? Right, I want to, so you have two things, right? Objective and constraint. I want to move this guy down as a constraint, right? Because we have no problem with dealing with the absolute in the constraint. We have zero problem with that. If we can do that, then we know how to do it. Make it -1 or 1. No, we're gonna do exactly like what we did last time. So for example, this guy is problematic, right? What we're gonna do is we are going to change all the absolute to ti, right? Remember last time we changed the absolute to t, but except this time we have more than one absolute. We have multiple absolute, right? They're gonna change each one to ti, and then all I need to do is move this thing down to gi minus boss I, right? It's less than or equal to t. I. Apa saja? I'm good so far though, right? If what I did is essentially I just redefined this as a variable t. Okay, I redefine this as a variable t. Okay, and then now we know what to do with it, right? So this thing gonna need to be, so this thing gonna become that gi minus boss I has to be less than ti, and gi minus boss I has to be greater than or equal to minus ti, and then now you can solve exactly what you need. Don't worry, people actually take a term to learn all these tricks, but I just show you that it is possible. I want to show you that it is possible, that's all. To do this, so for example, this is how you need to do, right? Once you do that, there's a total gap that is, let's say the diff between the boss and you, right? So it's gonna be boss GS minus the boss. Okay. Okay, and T is now a array. Right, so we just need to say that this thing is less than T and greater than minus T, and then you're done. Name bosses is not defined. Okay, it's up there. Minimize objective must be solved to a scalar. It is a scalar. Why is it not scalar? Put all the dots. All the dots. Minimize objective must be scalar. Oh, sorry about it. It's a vector, so you want to sum. So it tells you, okay, loss, this is how much you should produce. I think this is the number to be sure. Can do this. Print of CS. Okay. Okay. So this is actually very close to what your boss is saying, right? Your boss is telling you that the first one should be 80, so let's give you 73. Boss, this is close enough. And 15, I give you 9. 15, I give you 9, and 15, I give you 7. The third one. 7 good. If I look at the time, actually, let me skip 355 and 356. You can actually look at the spoiler yourself. It's actually a fun thing to do, and 4 as well. Let me skip this. We may come back if we have time. Okay, but I want to show you that you can deal with maximum as well. You can deal with maximum and so on. You can look at the spoiler if you want. Let's skip this to a much cooler one, to a much cooler problems. Any questions so far though about the linear optimization that I show you that it's actually versatile, right? That even though you say that Ajahn, but it can only solve the problem that looks like this, it can actually solve you a problem that looks a lot more complicated. Okay, so for example, the absolute we can do it, absolute in the objective, absolute in the minimum, or even the sum of the absolute, you can do it. Okay, this thing is actually quite useful when you want to fit some line. Okay, so let's do number 5. This is what I really want to teach you today. Okay, so for this one, I want you to pay attention. This is very important. This is how you do algo without having to do it. If you can turn your problem into linear optimization, which a whole bunch of problems can do, okay, then you just let this engine solve it, the single engine that solves every problem. Okay, so for example, if you think about our food problem, right? Our food problem, you figure out that okay, you're gonna need 0.8 gram. Let's say you said you want 80 grams of chicken rice, but chicken rice you can only sell a plate or 2 plates or 3 plates. And each plate, I don't know, each plate can have, I don't know, 100 grams. Then you cannot go to Pa, can I have like 0.83 plate of chicken rice? Pa is gonna tell you, no, you cannot do it. You only have 1, 2, or 3. So a lot of problems in real life, right? They are not a floating point problem. They're not floating point problem. Okay, you do not have choice, all the choices between 0 or 1. So some of time, a lot of time, the choices you have are either 0 or 1 or 2, right? And the engine that we use is actually support that. This is called mixed integer optimization. Okay, which means that some of the variable are going to be integer. This actually makes the problem like tons harder, much harder than the floating point. The floating point is like O(n) to the 4th, right? But mixed integer optimization is actually NP problem, but they optimize it so well. It's still exponential, but it's still fast. Okay, so that's good. If you're interested in how exactly they solve it, look at these 2 terms, relaxation and branch and bound. Okay, but your problem is actually quite simple. So let me show you how you do it. So for example, now you want to solve the chicken rice, cake, and noodles problem, but you want to solve it as an integer, right? You want to solve it as an integer. So that means what you need to do is you need to define. These are your variable, right? The thing that you want to adjust your variable. The thing that you want to adjust to be the number of plate for chicken rice, the number of plate for cake, the number of plate for the noodles. And for each one, you can calculate exactly how many grams of chicken rice you have, right? So for example, 200 grams per plate, right? Or 100 grams per cake or 200 grams per bowl of noodles. Okay. So after you define this, and then you do exactly what you did before, right? The usual thing to define all the variables in your constraint and your objective, then you can let it solve it, right? So it solve it right away that, okay, you should eat 2 what? I think it's 2, this guy, cake and 1 noodle, that's it. And this is the amount of calorie that you're gonna get, right? It solve it right away. You might think, Ajahn, but it's very limited, so on and so on. Everyone see, right? Let me give you this example. Okay. Then I'm gonna let you do next example. Okay. Okay, this is a very easy example, right? Chicken rice, the plate, and the number of noodles. Any questions so far though? So all you need to do is these 3, but the mathematics behind it is much harder. I can tell you, much harder to optimize it with an integer, because any graph theory problem is an integer optimization problem. Like which one you choose to go, right? Which brand are you picking? That's an integer. That's an integer one, because you either pick it 0 or you either pick it 1 or you don't pick it 0. Right? If you have finite amount of choice, it's actually much harder than having continuous amount of choice. Kind of ironic, right? If you think about it, infinite choice actually is easier than 2 choices. It actually has to do with how you find the gradient and so on. Infinite number of choice is actually much easier. Okay. For example, let's look at this. Let's look at this problem. This is real life problem, and you're gonna save a lot of money, especially if your family business is some sort of factory or some sort of project. So for example, let's say you have 4 jobs to do. Okay. Let's say you have 4 jobs to do, A, B, C, and D. This could be some software, right? This could be some software project. So for example, you need to do project 1, which requires 3 people to work on a month, right? Or project B, which requires 5 people to work on it straight 2 months. Okay. And project C is required 2-man month. So 2-man month means 1 person. If you use 1 person, it's gonna take you 2 months to do it. If you use 2 person, it's gonna take you 1 month to do it, right? That's what it calls man month. This is the total unit of job. So if you have 5 people, it's gonna take you 1 month to do it. So that's okay. And that's a deadline such that B needs to be done before 2nd month. So for example, this is clear that A, because it requires 3-man months and the deadline is 1 month. So that means you need to hire 3 people for sure, right? You need to hire 3 people. Okay. But for this one, you can hire 2 people if you like, right? So the thing is, what you want to do, right? You want to hire people, but you don't want to fire people because if you hire and fire them, you need to pay a whole bunch of fine. Okay, so you want to make a schedule, right? This is what you want to do. You want to make some sort of a schedule, right? So for example, the picture on the right. So you have A, B, C, and D. You want to make some schedule such that you want to make sure that let me make this guy as well. So that's deadline 1, 2, 3, and 4 months. Okay. This is month 1, month 2, month 3, month 4, right? You want to make some, okay? Let's say you hire 3 people this month, okay? You hire 3 people this month, and B require 5 people for 2 months. You can do the following, right? You can hire 5 people right away, right? And do it for 1 month. But then they're going to be free for the rest to do some other job. And then you can say that, okay, these 5 people, some of them going to be free, which means I can take 2 people on this month, right? 2 people on this month to make sure that they finish by month number 3, right? To do the job, I don't really need to hire more people, right? And number 4, then I can get 1 person here as well because he's free from that job already, right? He is free from that job already to get things done before month number 4, right? So in total, if it looks like this, then in total, you need to hire 8 people, right? Everyone clear, right? You hire 8 people, and not only that, you don't have enough job for them to do like in these 2 months, right? You don't have enough, a lot of them going to be free. A lot of them going to be free in month number 3 and month number 4. And I don't know, 5 people free here, then you pay essentially free salary, right? You pay essentially free salary. Okay. The question is, can anyone give me a better schedule? How do I manage this without hiring like a whole bunch of people? Can you give me a better schedule? Okay. This is actually a real life problem though. Real life problem. If you are now CEO, you have 1,000 employees, how would you schedule them? How do you assign them to each of the unit? What do you think? Can you give me a better schedule? Anything better than what I drew earlier? What I drew earlier is like one of the worst case that you can do, right? You need to hire 8 people. What do you do? To make sure everything is within the deadline. The deadline is here, right? This line of this guy is here. This line of this guy is here. This deadline of this guy is here. So for example, let me show you another schedule that looks better. What if I hire 3 people here to meet the deadline? That's the only way to do it. I hire 2 people here to meet the deadline, right? And you hire 5 people, then you don't do B at all. You don't do B at all, right? You don't do B at all. And then you hire 5, then you don't need to hire the new 5 people, right? Because these 2 people, these 2 guys can help with this job. And you finish it before the deadline as well. Oops, sorry, the deadline for this guy is here. Right? And then because you have 5 people, you can have 1 over here. I think this is one of the best schedule you can have. Unless some magical thing happens. Sound good? So for this one, that means you only need to hire 5 people. Okay, even though most of them can be free at the end, but you hire like 3 less people than the other solution. So the question here that I want to ask you, what is the minimum of number of people, this number of people that I need to hire? Are we good? Okay. And of course, you cannot hire like 2.5 people. You can hire 1, 2, 3, 4, 5 people. That's what you can do. Okay. So we want to phrase this as linear optimization. Okay. We want to phrase this as linear optimization. So the question here, if we want to optimize something, we want to know what is the parameter we are adjusting, and then we can make a constraint. What is the variable that we are adjusting? Can you tell me? How would you define your variable? How do you define your variable? Which is now getting to the point where you start to be able to do algo. This seems like an algo homework, right? This is called scheduling problem. You probably learn how to do it with dynamic programming. Did you learn dynamic programming already in algo? Yeah, this looks like a dynamic programming problem, right? What's the best schedule? And you have a whole bunch of constraints. Now, I want you to look at this as another perspective, from another perspective. Now, I want you to look at it from linear optimization problem, right? So here's the thing. What are the numbers you want to adjust? You can just tell me qualitatively as well. That's probably correct. I want you to look at this from another perspective. Higher amount, good. It's essentially this table, right, that we want to adjust, right? It's essentially this table we want to adjust, right? So we have what? A, B, C, D, right? Month 1, month 2, month 3, month 4. So you can define your variable as an array. Yes. So now you have 16 number to do, right? You have 4 months and 4 jobs. So you have 16 variable in 4x4 matrix. Okay. Now you need to, so these are the numbers that you want to adjust. There are 16 number. Each one of them can be integer, right? 16, let's call it integer. And 4x4 matrix. Okay. So let's think about this. Let's think about this. Let's look at the constraint. Let's look at the constraint. So the first constraint is, how do I make sure that every job is finished? Not may or may not be within the deadline though, but at least I want to make sure that every job is finished. How do I make sure though? Anyone has a good idea? How do I make sure that every job is finished? Given this schedule, how do I make sure that every job is finished? A, B, C, D reach certain amount. Very good. Or you can say that the sum of each row, right? The sum of each row needs to be equal to the number of man month required, right? So we say that the sum of, let's call this matrix A. Let's call this matrix A. The sum of A, which is going to be the job and the month, right? Sum over every month, right? This is what it means to sum each row, right? Has to be equal to the manpower required. Let's call that manpower. Power required for job J. Let me put just this. Is everyone good? Right? And then we put in the qualifier for all J. For every job, this has to be met. You want to make sure that everything is fine within the deadline. No, it's fine. It's finished. It's finished. Is someone good? Any questions so far though? Any question? Any question? I think this one is pretty obvious, right? You just sum the rows. So for example, to make sure that job number 1 is finished, you could do 1 here, 1 here, and 1 here. At least it add up to 3, right? That means you know for sure it's finished. But with or within the deadline, I don't know. Okay, everyone good? Now, the second question I have to ask you is, what about the deadline? How do I make sure that everyone meets the deadline? Right, so for example, the deadline for the first one, the second one, the third one, and the fourth one looks like this. How do I make sure that they reach the deadline? How do I make sure they reach the deadline? How do I constrain it? Anyone has a good idea though? Has a good idea. How do I make sure that they meet the deadline? This may not be so obvious. Each sum to deadline only. That's actually not a bad idea, but you can make it much easier. You can make it much easier. You can make it much easier. That could work though. What Saran was saying could work. After the deadline, what kind of number you can put here? What kind of number you can put here? For a valid job, what kind of number you can put in the yellow box? What number you can put in the yellow box? 0, right? So that means A, J, M equal to 0 if J greater than or equal for all, actually, let me write, for all J greater than or equal to deadline M. That's good, right? So with these two, you guarantee. This is exactly what Saran was saying, that sum up to a certain point, but that also means that the rest has to be 0. Sum up to the deadline might be easier to write. That depends. Actually, sum up to the deadline is easier to write. Okay. So, yeah, they are both equally easy to write. So, now, we're not done yet, right? We're not done yet. We don't have the objective yet. We have the constraint already. We need the objective. How do I write the objective though? How exactly do I write the objective? Not a bad idea, right? So let me do this. Let me put the spoiler so you have something to look at. So this is what we did before, right? So the objective that we want is this number. It's this number, right? For each month, you can say that the higher people for each month, right, is going to be the sum of all the job of AJ, sum over all the job, right? And then what you want to do is you want to minimize the maximum number, right? You want to minimize the maximum number. This is what you do. Let me show you. Want to minimize the maximum number, which is what I skipped. Let's do it here. Let's do it here, right? So this is what you want, right? Minimize the maximum number among this. So we want to minimize the maximum. So let's call this. We want to do argmin of our schedule such that it's maximized over every month of HM. Sound good with me? Okay. Okay. So let me put everything. Let me put everything in one line. Right. Oh, actually, yeah. I did exactly what Saran was saying in the notes here. Okay. Let me write everything down as the objective. So this is your problem, right? Your problem would be to minimize what? Over the matrix A of the max such that we want to find maximum over M HM. This is the number higher. Okay. for the month. This is how much you need to hire. And then subject to, okay, subject to, you say that the job needs to be done. So that means the sum AJ and M over every M has to be manpower for job J. Okay, so this thing is job done. And then within the deadline, you say that A, J, and M has to be 0 for all J greater than or equal to, for all M greater than or equal to deadline J. Greater than or equal? Depends on index +1 or -1. You can fix this one later. Okay, so far so good. And then there's something like A, you cannot hire negative people and so on. Something like this for all J and M. Okay, so far so good. So you see that's one problem. This is called point-wide maximum. It's actually called point-wide maximum. So that means you are selecting the maximum from a whole bunch of numbers. So for example, you select the maximum from this number 3725. It's actually linear though. It's actually linear if you think about it. Okay? It's actually linear. Okay, so here's how to make it linear. Watch carefully though. Watch carefully. Here's what I'm gonna do. Most of the time, here's what you do. You move the thing that doesn't look like linear to the constraint, right? So I introduce another variable, right? T, and what I can do is I can do the following. I can move this guy down, and let's say that this guy is equal to T. Okay. Move that guy down and make that guy equals to T. That's still the same thing, right? I just redefine the variable. Okay. And the next thing that you can do is I say that, oh, wait, T is the maximum among all these, which means I know very one thing, right? That T has to be greater than or equal to all the HM, right? That same T needs to be greater than or equal to HM, all of them. Or in other words, this guy becomes, let me put the box around this guy. This guy becomes, I know that T has to be greater than equal to HM for all M. And now everything is linear. Are we good? Are we good? Any questions so far though? Any questions so far though? Because T is the maximum, I know T has to be greater than every single element. Okay, actually it's these two guys that work together to make it possible. Okay, so give me the schedule and then you're gonna be so proud. And you're gonna think, okay, Ajahn, this thing is much easier than writing a graph traversal. Much easier than writing the dynamic programming. Okay, I'll let you do it and then I'll help you later. Okay, look at the example here and all that you did before. This one should be much easier. Okay, so let me help you. You define your variable, right? A is a CP variable. And it's what? How much? 4, 4? That's how you define array. 4 must be a string. Yes, like this, 4, 4. Okay. Then, so let's make a note here that J job is first index, and month is the second. Okay. Job is the first index, the month is the second. So this thing is, so I say that. So job done is a constraint to say that a cp.sum a, show you the syntax, a oh, sum every month, right? J and n. I can write this in one line, except you're not gonna be happy with me. What did they do in the solution? There might be a much better syntax. 2 seconds. Let me look at the sheet. Ah, I can sum over the axis. That's the cheat sheet. Axis is the first axis. Now over every month. Okay. Has to be equal to the manpower. Yes. And deadline. Deadline met. CP dot. I think there's something magical. So dot. And says content deadline. Zero. Oh, the higher amount is going to be I need a variable called t. Okay. Oh, I forgot to tell that A is an integer. It may not matter. 0. Oh, okay, that works too. You can put it in one by one. I try to be smart, except then I give up. And that's how you should do it. Oh, they can even do 4. That's actually very smart. That's actually very smart. That's actually clever though. I wouldn't have never thought about doing a schedule that looks like this. Okay, so there. Like enough for your dynamic programming. This is all you need to do. Specify as a constraint an objective, and then it's going to solve for you. And I believe there is also a theorem, a lot of theorem that if certain condition is met, you don't really need integer is equal to true, and then it's going to become integer for you. So for this one, it's actually close enough. 3 and 1, and 4 and 2 and 6.5. Okay, you cannot do that. Maybe the condition is not met for this one, but there's some theorem that say if the condition is met, then you can just optimize it as usual. Okay. I don't know. I don't know how you feel, but the first time I see this, I was like, come on, why do we learn algo? Actually, algo is a lot faster, but this thing get the job done. This thing get the job done as well. And most of the time it's fast enough. What you learn in algo is actually faster. I don't know, as a homework for like algo exam or something, you can try solve this one with dynamic programming. I think you can do it. I haven't figured out how to do it, but this one should be able to do with dynamic programming with this kind of constraint. Okay, so let's look at the next one. Let's look at the next one. Let's look at the next one, and I think we can do 2 more problems and then we can call it a day. Okay, the next one. This is actually our goal problem. It's called maximum bipartite matching. Okay, this is a very, very, very important one. This is actually how they match. This is actually how they match donor and receiver for the organ transplant. For this one, it's for money though, but this is actually how they match donor and receiver for transplant. So there is a fitness, right? So for example, if I give my liver to Saran, there is certain cost associated with it that they calculate already that, okay, this guy gonna live on and become a great people, like there's a certain age of you, they're gonna live on more than 20 years or something, and then they're probably gonna maximize the total number of years everyone lives, right? But of course, my liver exists only once, right? You cannot have 2 of my livers, Saran. Sorry about that. If you sell one of yours for iPhone, then I can only give you once. So there are certain costs or benefit associated with each of the, what's it called? Each of the donation. So for example, if I donate my liver to, let's say R1 is Saran, receiver number 1 is Saran, then I get 3 points, right? If I donate to, I don't know who is up the chat, let's say I donate to Adil, then I get 2 points. I donate to Van, I may get 1 point. If I donate to, I don't know, whoever that is, number 5, I get 0 point. But I can only donate once. And not only that, you can receive exactly once, right? You don't want to do the surgery 2 times. Okay. So that means this problem is like picking the number for each row, right? It's like picking the number for each row. So for example, let me just copy in this. And then we have technology that I can paste it here. And it's so small. Okay, now it's bigger. So this problem is like how you would circle each of the number, right, to get the maximum. Now I need to 1 and I need 2, something like that. Okay, so far so good. Well, this one is not possible because this number 3 is donated already. So lock, and that's screwed up. So this is actually not easy, right? So if you do this, you may think, okay, Ajahn, you should pick 3 over here. No, you can't, because you need to pick 1 over here. And once you pick 1 over here, you kind of screw because this guy is gonna get 0, right? So you say, okay, I'm gonna fix. Maybe can I pick 3 over here? No, you cannot pick 3 because number 3 has only 1 liver to donate to you. Then you need to pick 1 and 2 to maximize it. So you can kind of see that this problem is actually not trivial. There might be some better solution. Like last time for the schedule, right? It's this thing it's actually not trivial. Like you need to split the number 2 to 1 and 4 to get the maximum number of pi to 4. Kind of work. So for this one, we can actually form it as linear optimization. You may not think, Ajahn, that doesn't look like linear at all. It actually is. It actually is. The question is, oops, how do you define your variable? Okay, right? So this is a problem of picking one. Each one, everyone has something, but I want to maximize the total number. Anyone has a good idea though? What is your variable? What is your variable? What are you trying to adjust? Right? Last time, what we're trying to adjust is the number on this matrix. This time, what is the number we are trying to adjust? This problem is actually very short if you know what you're doing. What do you think? how should our variable look like though? What do we adjust? So our variable should tell us one thing like who I should donate to and whatnot, right? How would you define such a data structure so that you can look up who donate to what? Imagine this matrix to be like really, really big. Anyone? How do you define the variable such that we can read right away who I donate to? How do you do it? Anyone? I want you to think along though, because this is actually the most important process. Not how to write CVXPY, because I'm pretty sure you can Google that one, but how to turn your problem into something computer can solve. This is what I want you to get from this class. Anyone? Any guess though? Any guess? I'm accepting wrong answer. I'm accepting joke as well. Anyone though? This one should be obvious though. This one should be pretty obvious. Anyone though? Anyone? Okay. The most obvious way to do it, right, is to, okay, Ajahn, because you circled this, what I did, I circled this. Think about this. The game here is actually you can circle each number, right? So you want a data structure of some sort, right, to store what you are circling, right, Saran? So like last time, this guy, you want data structure of some sort to tells you how many man months do I need for each job, right? So for this one, I kind of need to know, right, which one gets donated to who, right? Or which circle am I making, right? So the simplest way to do this, is to make another matrix 5 by 5, right? 1, 2, 3, 4, 5. And actually, I have a grid paper. Why do I bother? Check. Okay, that's better. Okay, so 1, 2. That's worse because it's too small. Actually, let me just use this. So we're gonna make a 5 by 5 grid, and then let me put in this guy a box. Give up on technology. Okay, so to do this, we want to make sure, I want to know which one I circle. So I'm gonna put number 1 and 0, right? 1 for if I circle and 0 if I don't. I actually need 5 by 5 grid. 2 seconds. So this is receiver 1, receiver 2, receiver 3, receiver 4, and receiver 5. And D1, D2, D3, D4, and D5, right? So for the one that I circle, I'm going to put 1. For the one that I don't circle, I'm going to put 0, right? So that's good. So each element, right? So you're going to have 25 number in 5 by 5 matrix. And each element is a Boolean, it's 0 or 1. It's an integer, right? It's 0 or 1, it's an integer. So that's good. Let's call this matrix A because I like to call matrix A. Is everyone good? If you see this matrix, you know right away like who I give the kidney to, right? You know right away who I give the kidney to if you see this matrix. Are we good? So this is going to be your decision variable. Okay, the technical term is called decision variable. Okay, so we need to constrain this variable. We need to constrain this matrix A. Okay, we need to constrain this matrix A to do a couple of things. So for example, I say that, okay, you only have one kidney to give to people, right? You only have one kidney to give to people. So how do I make sure that you only give one though? How do I make sure that you only give one? Any suggestion? How do I make sure that you only give one kidney to people, not two? Because you only have one. Hey, one. Did I say kidney or liver? Liver. You have one liver, two kidneys. How do you give equals to 1? So you can do like what you did last time, right? What you did last time. You want to make sure that the sum of this row, right, is 1. Right? So you say that's a what? RD or DR. Right? You want to make sure that sum over R is 1. Right? And then the same idea that you can only see one liver from people, then you want to make sure the sum of A, sum over D of A DR is 1. Right? Now you constrain that you only have this kind of solution already. Everyone with me so far though? Everyone with me so far? By the way, Sudoku can actually do this as well. You can actually solve Sudoku with linear optimization. Okay. Any questions so far though? Now you constrain it that the donor can only give 1 and the receiver can only give 1. Now we need the objective. What are we trying to maximize though, right? If you remember, we're trying to maximize, right, the circle. We're trying to maximize the circle number, like so for example, number 3, whatever number you circle, you want to add up to like the maximum amount. To add it to the maximum amount. What do you do though? What do you do? How do you calculate like the score? The score. How do you calculate it though? Anyone? How do you calculate it? How do you calculate the score though? Right? I want to make sure that I only add the number that I circle. Right? The number that I circle. So for this one, it's gonna look like for this one, it's gonna be I add 3, 0, and then 3, 0, 1. How do I add up? How do I calculate it though? Anyone has a good answer? What do you do? What do you do though? What do you do? If I want to add up all these, right? So you may think, okay, Ajahn, I will need the if statement, but no. All you need is math, right? You know, one very important properties of multiplying is if you multiply 1 to 3, you get 1, you get 3, right? You multiply 1 to any number. Close, but not quite. You multiply 1 to any number. You multiply 1 to any number, you get the score. You multiply 0 to any number, you get 0, right? So that means all you need to do is to multiply this matrix, right, with this matrix, right? And then sum up every number. That's what you're gonna get. So all you need to do is A, and then this thing is element-wise multiplication, S, and then sum. That would be all, right? And these 3 lines gonna give you the best donor receiver pairs. Are we good? Someone good? Someone good? Seven agree with that is the sum of A times S, and that's all. Okay. So you may think, Azan, this problem maybe is easy. It's actually really hard, this problem. This one is learning counting. The number of solutions, right? The number of solutions, there are n factorial solution. In this case, 5 factorial, but you can imagine if there are 1,000 people, 1,000 factorial, that's just impossible to do. Right? And then you go figure out why it's 5 factorial, but it's 5 factorial. Okay, so let's write these 3 things. I'm gonna let you do it. I'll let you do it. Actually, I'm gonna help you do it because I really want to teach you the coverage problem. Because I really want to teach you the coverage problem. Coverage problem is much harder. But let's do this. So you need to define your variable. Okay, cp.variable, and it's 5 by 5, right? So we do this. 5 and 5. So that's your A. Now, your thing is going to be so short, cp dot, so your problem is going to be cp dot problem. Then you want to be, say that the objective is cp dot maximize, because you want to maximize the score. cp dot sum of A times S. Actually, let me just write it here because I want to know the score. Score is A cp dot sum A times S. That's all. Okay. Subject 2. Right. Subject 2, that each row it needs to add up to 1, right? So subject 2, cp dot sum A and axis is 0 equal to 1, and A dot axis is 1 is equal to, and that's it. Looks so magical if you try to do this with a search. There, and S is not defined. That's it. 29. I don't know how they do it. So you probably want to print, right? A dot value. Oh, I forgot to tell you that it should be an integer. Not integer. It's called Boolean. I think it's called Boolean. It's true. Bool. Second, what does it call? This thing is stupid. Integer is equal to true, and then I just say that A is between 0 and 1. Okay, sure. A is less than or equal to 1, and A is greater than or equal to 0. Okay, there. That was good. There. That's what you need to do to get the maximum. What is the maximum though? That doesn't look like maximum to me though. What did I screw up? It looks like a valid answer, but doesn't seem to be a maximum. Did I calculate the score correctly? Oh, that's probably matrix multiplication. Sorry about that. How do I get it to do multiply? Ah, okay, sorry about that. How do I get to get it to do like element-wise multiplication? This is what you need to do. VP dot multiply. Yeah, but again, the whole point of today is not how to use CVXGY, but how to turn your problem into something CVXPY, or how you turn your problem into a linear optimization problem and then get it to solve. This problem sounds like your algo homework. Probably Ajahn Sansert gonna have you do it somewhere. Or maybe Ajahn Krat, I don't know who teaches this term. I think Ajahn Sansert, right? Be nice to him though. He's gonna get I think a baby either today or tomorrow. Be really nice to him because he's gonna be really, really sleepy coming to class. Okay. Any questions so far? Though? Any questions so far? I think it's pretty cool, right? You're gonna get 10 points from here. So what does it pick? 3, 3, 1. Well, okay, kind of 1, 1, 2. That's exactly what they did, right? No, they did not do that. What did they trick? I erased it already. But get 10 points, you cannot go beyond this. Are we good? Okay, any questions so far? Or any questions so far? Now you can see that it can actually solve. It's not a theoretical toy that, okay, that's an equation that you can solve. But if you can turn physical problem into linear optimization problem, then you can solve a whole bunch of problems. Okay, especially a whole bunch of a graph theory problem that you learn in algo can be turned into linear optimization. You're not going to get the best big O though, because typically you can exploit the graph structure to do something much smarter than this. But this is like the tool that you can use to solve all of them. Okay. Any questions so far? Though? Any questions so far? Okay. This one is fun. This one is fun. Let me show you. Let's say you are a terrorist. Actually, because it's on the record, let's make something nicer. Let's say you are AIS. Let's say you are AIS. So let's make sure that I don't teach you how to like do the maximum damage. So I'm going to change the story a little bit. The story here says the following: that all the dots over here are people's houses. You don't want to bomb it though. What you want to do? You are AIS, right? You are like telecom company. You want to place the antenna right on top of the house to make the problem easy. It actually doesn't matter. You can place the antenna anywhere you like. Okay, so you want to place the antenna on each house. Okay, but if you place it on this house, these people gonna have the coverage already. So that's good. But this guy over here, oh, you cannot see my mouse. Sorry about that. Let me just copy the picture. Sorry about that. My mouse is gone. Sorry about that. I don't know why my mouse is gone. It shows up yesterday. Okay, this is better. Okay, so these blue dots here, they are houses. Okay, and this guy is antenna. Okay, you want to place antenna on the house. This is for simplicity of the problem. It actually doesn't matter. Okay, and if you place an antenna here, what happens is that these people, right, within the blue range are going to be covered. Okay, these people are going to be covered. But this guy over here, because antenna is here is like sad people, right? You have no signal. It's like your house that has bad signal. So you are these people who have bad signal. Okay, so far so good. The question here is, okay, Ajahn, easy. If you want everyone to have signal, right? You just put antenna on top of everyone. Yes, you can do that. But that's a silly thing to do because each antenna is going to cost you a lot of money, right? So far so good. But you want everyone, right? You want everyone. But you want everyone to have cell phone signal. So, but you want to save your money as well. This is actually a true problem though. I actually did this for PTEP and they love me so much for this problem because it saved them like so much money. I stopped something similar to this for them. Okay, so for each one of them, you want to make sure that you cover everyone with the minimum cost. The faster good. And I want to know, right? And I want to know how many antenna do I really need? Okay. How many antenna do I really need? Okay, someone good? Everyone understand the problem, right? You want the circle to encompass everyone, but you want the minimum amount of circle because each circle costs you tons of money. Okay, so the constraint are cover everyone. That's it. That's it. You just want to make sure that you cover everyone. Okay, so to help you with that, I actually calculate something for you because you're gonna need this. You're gonna need this. Okay. So here's the thing. So CBP, this is a matrix, right? That is 0 or 1. It tells you the following. If I place the antenna here, does it cover the other house? This is the entry. So for example, this entry, let me print the first few ones. Let me print coverage 415, 415, for example. Okay, so for example, if I place what's that called? The antenna on house number 2 is gonna cover house number 5. Are we good? If I place, well, on number 5, it's gonna cover number 2. That's like symmetric, right? So far so good. So this is, I turned this graph into this matrix already to help you because I know that you need it. Okay. The question is, right? Remember, the real question that we want to answer is how many antenna do we need? Okay. So we're gonna turn this into a linear optimization problem that you may think, that doesn't look like linear optimization problem, right? This problem is much harder than you think, right? Think about this, the space of the thing that you need to search is how much? Can you tell me? If there are n houses, how many solutions exist are there? How many solutions are there? Even bad solutions. Can you tell me really quickly? If there are n houses, how many solutions are there? Anyone? Anyone? For each house, what you can choose, what can you choose for each house? You can choose to either place antenna or not to place antenna on it, right? So you have 2 choices for each house. So how many choices do you have in total? 2 to the end, good. Which you should scream because you learn from you learn from algo already. Anything beyond exponent, beyond what's that called, to the fourth, anything beyond polynomial degree is a bad idea. This is exponential, is a bad idea. But this guy can solve it in no time because of some tricks. Okay, so far so good. So this is what we want to do. Okay, so searching this is like sad life. I don't know how many houses are there. How many did I put? 100, 2 to 100. That's even more than the number of atoms in the universe. 2 to 100. No, you don't do it. Okay. That's actually a good interview question. What's the theoretical limit for the hard drive size? Okay. So let's do this. Anyone has a good idea though? We need some constraint, right? We need C, the coverage. C of B and P. Let's call it A and P. This is antenna. And H, this is the house. Okay. Equals 1 if placing antenna at A, cover H, and 0 otherwise. Okay, so the first thing that we need to do is to figure out what is our decision variable, right? What are we trying to vary? What exactly are we trying to vary? What kind of data structures you want to use to vary the place that you put in the box? What would you do? Ajahn cannot gonna scream if you do this, but you should do this in this class. Well, what should you do? If you want to know where the antenna are placed, how would you store it so that you can adjust it? How would you store it? Anyone has a good idea? Anyone has a good idea? Anyone has a good idea? How should we store it though? Give me the simplest one. And then give me the simplest one. How would we store it? You want to know where you place your antenna. Okay. So let me just tell you because we are running out of time. The easiest one way that you can do it, right, is, okay, what about this? I have an array. You're gonna look, it's gonna look really stupid. You're gonna have an array of 100 number, right? That's the number of house. And each one of them gonna say that it's 0 or 1. Right? It's 0 or 1, or 0 or 1, right? 0, 0, 0, 1. 1 means you place antenna at that place, at that house. Are we good? So this is our decision variable. Let's call that A. Okay, so far so good. Let me do this. Okay. Right. So then for this one, the reason I do this one is to make your life so much simple to get the total antenna. Right? The total antenna, all you do is add up all the A's, right? Total antenna. This is the total antenna. The bomb is an antenna. They actually use bomb down in the surface, down under the sea to actually do the sonar reflection. Total antenna is a sum of A. That's it. As simple as that. But now we have the constraint, right? And our constraints say exactly one thing. Please cover everyone. What do you do? Please cover everyone. It has to do with C for sure. Anyone has a good idea though? It has to do with the constraint, the coverage matrix for sure, right? Everyone has a good answer? We want to make sure we cover everyone, right? So think about this. This is a C. C has A antenna and H houses. What do you do with C and A, right? So for example, if I place antenna at A, actually it doesn't matter, it's symmetric, right? So let me put A over here. Wait, just erase and write the same thing. Let me put A over here. It's symmetric, so it doesn't matter if I transpose. So that means I kind of know, right? If I place the antenna here, I know that all of these houses are going to be covered, right? All these houses has the possible way to be covered. So that means I can also count, like, given a house, how many things cover me, right? I can also count how many antenna actually covers me. So this means that your constraint, you can write like this. Okay. You can write like this. So this thing is actually a what's it called? A matrix multiplication. So if you look at this, right? So the sum of CAH multiplied by CA. So this thing is going to be 1. If both of them are 1, let's just consider this. If both of them are 1, if the coverage matrix say is 1, if you place the bomb at B and bomb at B, cover house at P, then you know that this guy is going to become 1, right? This is going to become 1. Okay, and if you sum over every bomb, so that means the number that you calculated over here, right, is how many antenna covers your house. Everyone get? This is essentially how many antenna covers your house. And you want to make sure that every house has more than or equal to one antenna covers. Right? And that's all you constrain. You need to think a little bit about how you count. Okay, but once you figure it out, okay, Ajahn, this is all your problem. Just 2 lines of math. And this saves people like millions of dollars. Okay. Any questions so far or any questions so far about how I turn this? Are you convinced though that this is like the number? This is the number of antenna that covers the house. Okay. If no question, let's just do it. Let's just do it. It's actually very short. So A is going to be CP dot variable. And it's called coverage, right? And it's the same thing as coverage dot shape. Okay. So A is CP dot variable and coverage dot shape. And all I need to do is my objective, right? Total antenna is CP dot sum of A. And then thing over here, I think it's matrix multiplication. Let me just look at the sheet code. Nah, it's probably matrix multiplication, except I'm too lazy to do it. So it means that just do the sum, right? For every one, I just count how many covers them, and then since I sheet already, so I'm just going to sheet everything because I'm too lazy to type now. Print A dot value is none because I forgot to tell that this thing is an integer. Actually, there's a way to tell it that it's 0 or 1. Boolean equal to true. That's what I thought. It's very common that you have a Boolean variable. It's very common. And come on, it's 2 to 100, so wait a while. Why does it take so long? Interrupt. No, I cannot interrupt. Great. I cannot interrupt. Can I restart? M1, please tell me I can restart at least. No, I cannot restart. Great. No, I restarted it already. Sorry about that. Let me think. If I can restart, that means it's actually finished computing. Which is not defined. So let's do this. Let's wait. Let's wait a bit. And the terminal may say something though. It depends on the solver, how smart it is. But it's 100 by 100, so it's pretty large. Oh, I was stupid. Sorry about that. That's why it looks weird. Sorry about that. It should not be coverage shape. It should be just one dimension. It's only 100 number. Interrupt. Restart. Whatever I can do. I need you to restart. Da, da, da. There. That's it. Okay, it should be that fast. That's what I thought, it should be that fast. And then you get, this is the problem that you're trying to solve. That you should use, I don't know how many, what did I say? 1, 2, just bring total what antenna? Right. How many antenna are there? 10. You only need 10. Okay, so you need 10 antenna. And this is the place that where you should pick. Okay, so you see, these 2 lines is so powerful. Okay, to do this. Any questions or any question? I want to show you how powerful this is in solving your problem. Most of your algo problem can be solved this way. I think you're gonna learn it. If Ajahn cannot teach you like, what's it called? Computational theory. He might teach you how to turn one problem into another. There are equivalencies of problem that you can turn one into another. Some of them are not so obvious. Most of them are actually not so obvious on how you turn one problem into another one. Okay, and this problem is actually called coverage problem. It's actually a pretty famous problem. Okay, any questions so far though? Any questions? Okay, any question? Before we go, I want to remind you one thing, that in this class, we do have a project, but project is not something like really serious though. The project is something I want you to try to do something you never thought you can do before. So for example, today we are learning linear optimization, right? If you write, let's say, a Sudoku solver, Sudoku can actually turn into this kind of problem. If you write a Sudoku solver with this, and I'm happy. It doesn't even need an interface. If you just show me that it's possible to do it, you could use the library like CVXPY if you like, but what I want you to get from the project, okay? The project, the topic is to do something you never thought you can do before, right? So for example, some people do, this is one of the more fancy ones. They do Monte Carlo shading, like how 3D world works, right? How do you do the lighting? Some people do, let's say, the game of finding the difference, right? You what's that called? Finding the difference between 2 pictures. What's that game called? Spotted? No. Spot the difference, really? Right, something like this picture, right? If you write automatic program to actually tells you where they are. So for example, the mouse over here, the lollipop, the mouse is holding, right, a difference, then it would be great, right? Or some people do something like something that doesn't look hard, but it's very hard, like scaling the image. So for example, scaling the image 2 times is easy, right? Scaling the image 2 times is easy, but what if I want to scale the image 1.5 times? What do you do? It's not that trivial, okay? So the topic is something you never thought you can do before. Some people do something really fancy, right? So for example, take a wave file and then tells you like how many beats per minute are there. You can do Fourier series on that. Or take a wave file, you can tell all the notes. Okay, so it doesn't have to be anything fancy. It could solve something really simple. Someone could do it before, I don't care. As long as you understand exactly how it works. It's not just using what I don't want you to do is use the library and copy and paste without actually knowing what's going on. But if you copy and paste with actually knowing what's going on, then I'm happy. Okay. You can look at the tutorial on how to do it. As long as you learn something, then I'm happy. The project worth only about 10% of your grade. So just do something. Typically, I'm very lenient on the project. But tell me first if you are wondering, okay, Ajahn, is this good enough? If this is okay, then ask me first. Okay? So any question though, any question? And the project is still like at the very, very final day. Like after the final, the last day of the final week. Okay? Any questions so far though? Any question? Okay. If not, we're gonna call it a day. And I haven't graded your midterm. I'm gonna do it maybe this weekend or something, or maybe next weekend, because next weekend I'm going on a holiday. Then I'm in a good mood, and then you should get a good grade because I'm in a good mood. Okay. Any questions so far though? If not, then we're gonna call it a day and see you on Wednesday. Okay, see you next week. Bye everyone.